we will give an introduction to what IBM is doing in hybrid cloud and data and AI. So I call this presentation IBM Data Platform 2025, an overview for the DDO project. I am Henrik Sjöstrand. I call myself a solution architect within data and AI. And we have some other team members. I don't know exactly who is here, but John is definitely here, working with our cloud. We have Johan, who is a colleague in my team, also data and AI tech sales. I saw that Håkan, who is our CTO and community tech lead, was also here. And he's also very responsible for IBM actually getting enrolled into AI Sweden. So that's much appreciated. First of all, a lot of you may not know about IBM, especially not these years. Maybe you've heard that, I mean, we're more than 100 years old, etc. But what are we actually doing in AI? So just to get a quick glimpse, this is a chart showing the companies in the world who got the most patents in generative AI in 2023. IBM was the company who took the most patents, 1,592 patents in 2023. That's more than Google, more than Microsoft. And OpenAI released ChatGPT in November 2022. So you can understand that IBM has actually been working with generative AI long before OpenAI released ChatGPT. So we're doing a lot of research in Gen AI. I hope everyone can understand that. So this was 2023. Maybe someone asks, okay, what happens in 2024? IBM was not in the lead anymore. In fact, the leading companies were all Chinese. It's quite interesting. So in 2023, there were American companies and IBM in the lead. 2024, China has taken over. But luckily, IBM was the first non-Chinese company who took the most patents. So we're still doing lots and lots and lots of research on generative AI. So today, we call us the hybrid cloud and AI company. And this is a strategy that we set out, was it like 5-6 years ago? Very much driven by our new CEO, Arvind Krishna. And what does this really mean? First of all, hybrid cloud, it means that we develop solutions and products that can run everywhere, not only on a cloud, not only on-prem, but both on the cloud and on-prem, and also in any cloud. And AI, of course, it's both generative AI and all the new features and functions that come with AI, and also machine learning, which should not be forgotten. So we have a strategy, or rather we have a portfolio that looks like this. And this, of course, can be overwhelming if you look at it in just one slide. So let's break this down so you get a glimpse on what IBM is doing today. First of all, at the bottom, we have infrastructure. We still have our big mainframes. Banks, insurance companies, etc., are running mainframes. There is no plan to abandon them. They're more powerful than ever. And they're doing real-time inferencing of machine learning models on the mainframe chip today. We also have hybrid infrastructure. We don't have any laptops any longer. We don't have the ThinkPad brand. We sold that more than 20 years ago. We don't have x86 servers, but we have power servers. Quantum computers, if anyone is interested in talking about quantum, I can have a conversation about that. So we're doing a lot of kind of like big infrastructure. We also have the cloud division. John is part of our IBM cloud division. And our software can run on IBM Cloud, of course, but also on the other clouds. And we also have lots of enterprise infrastructure like storage solutions and some other things. Now, on top of this, we put Red Hat OpenShift. So as you all know, we acquired Red Hat like 5-6 years ago. and they're kind of like the crown jewel in our architecture. So Red Hat OpenShift is the platform that we're using for providing a hybrid cloud. And of course, Red Hat also works on the enterprise Linux and Ansible automation platforms. So Red Hat is a very important piece of IBM strategy going forward. On top of this, we build two different platforms. We have the data platform, which is what I'm going to talk about today. With some components, I will do a deeper dive into that in a few minutes. We also have an automation platform, and this is automation of IT. So making sure that the servers and the networks and the applications are running smoothly, monitoring memory, CPU, network utilization, optimizing that, etc. On top of that, we have a consulting piece. So we do have consulting, and I think that they will actually be part of this DDO project to bring in some of their knowledge into some of these white papers. And we work a lot with our partners. So I didn't see the names here, but I know that Aixia is part of the DDO project, Proact, etc. Some of the partners that we work with. So this is kind of like a view of IBM today. Almost 300,000 people. And when we talk about the enterprise infrastructure, I would like to highlight one piece, which is an x86 box specifically built for running OpenShift. We call it IBM Fusion. So this is an x86 box that we have developed closely with Red Hat to optimize it to run OpenShift very well. And this is being in production in Sweden. Some companies and organizations in Sweden like to run AI on-prem, and then you can use this box to kind of like kickstart that. So Fusion is a great platform if you want to get started quickly with AI on-prem. It supports our Watsonx platform and also the Red Hat OpenShift AI platform, of course. Then some organizations also try to find a way out of VMware after the acquisition, and they are looking at OpenShift virtualization as an alternative. And this box, because it runs OpenShift very well, is a good alternative to that. So, and in fact, we've actually put one of these boxes at AI Sweden's Edge Lab. So the red one here is a Fusion machine. This particular machine has 3 master nodes for OpenShift. It has 6 worker nodes. It has 1 particular GPU node, and we have 4 GPUs, 4 L40 NVIDIA GPUs. And we installed this machine last week, so Wednesday, Thursday last week, and we've only installed 1 LLM so far, just a sample IBM Granite LLM. Then we have software. We have Red Hat OpenShift Container Platform. We have some IBM data and AI pieces. We have Watsonx AI. We have Watsonx Data, governance, a data catalog, and a database. So this machine and these capabilities is available to use for everyone within AI Sweden who have access to the Edge Lab. So I think we need to work out the exact how to use it and for what projects and who will maintain it, etc. Kim and Stefan, but finally it's here and it's up and running. And as a matter of fact, I will use this machine for doing a demo of this stuff in a few minutes. But before that, I want to introduce a little bit more about our capabilities. So what is happening on the market today? Some of the building blocks for going forward. We know that assistants, this is kind of like the lowest hanging fruit. If someone asks, what should I start with? I say, usually start with an assistant. Questions and answers on your intranet, on your own documents. Assistants are really powerful today. But the next generation of assistants is really what we call agentic AI. So when they not only ask or answer questions, but they actually do work for us. All these, both assistants and agents, they need models. Assistants, they use large language models. Agents use large reasoning models or large action models. So models is really important, and IBM is training our own models. Data, of course, if you go to any organization and ask them why are they not really doing anything with AI, they usually point at, we don't have control of our data, we don't have sufficient data, we don't think we have good data quality. So managing your data is still in 2025 super important. And governance, being able to trust your solution, trust your data and trust your solutions. So these are parts that IBM is investing heavily in. And I'll just take some of these here. If we look at agents and assistants, for many, many years, decades, we've used machine learning for predicting and classifying, basically unstructured data. Then along came generative AI, and we could start work a lot better with unstructured data. We have the foundation models, they can predict the next token, etc. We all know that. We put these into assistants. An assistant, you ask it a question, it uses its own knowledge, its own training data, and it can provide an answer. And you can also ask it to use RAG, retrieval augmented generation, to feed in your own data and answer questions based on your own data. This is low-hanging fruit. And this is basically what the AI Sweden Svea assistant is doing. Now take that a step further, and we're moving into what we call AI or agentic AI. And this is actually AI that does tasks, that perform tasks for you. So instead of just asking it a question, we actually give it a complex task. And the models and the system need to think and plan and reason just like us human beings. And then they need to act and observe and make sure that they did the right thing and then get some kind of output. So here we use large action models and large reasoning models that not only can answer questions, but actually make decisions. So in the future, you're going to have lots of agents, just like you have lots of human colleagues and peers in your teams today. You're going to have agents that work alongside yourself. So this is what it's going to look like. You will have an orchestrator in the middle, orchestrating all of your different agents, like your new colleagues. These agents will call out to various backend systems. Let's take Salesforce, for example. If Salesforce wants to play in the future, they need to provide an MCP server, Model Context Protocol server, so that these agents can make calls to Salesforce services and run actions and get the information from them. And you can build these agents yourself, or there are pre-built agents, etc. And IBM has a solution for being this central orchestrator within a company. We call this Watsonx Orchestrate. So we have one software which we call Watsonx Assistant, which is kind of like the chatbot. And then we have the next generation, which is Watsonx Orchestrate for orchestrating all of these agents. So this is kind of like the new business process automation when you actually start using AI and agents to do tasks for you. I mean, this is all science fiction, isn't it? This is going to happen many, many years in the future. In fact, no. IBM have invested heavily into this technology, and we are using it every day. So at IBM, if we go to our internet, first prompt is ask IBM. So if I have a question basically on anything, I can ask IBM. This agent understands my question, and either it asks it itself or it calls out to some of its peer agents. So for example, we have Ask HR. If you're a manager within IBM and you need to move one person from one organization to another, one team to another, you go to Ask HR and you tell them, okay, move Henrik from this team to that team. And then Ask HR agent does that for you, does that for the manager. So the manager doesn't have to pull down menus and click and copy, etc. He basically says, move Henrik from this team to another team. So this has optimized IBM. We made a statement earlier this year that using agents and AI, we've actually saved over $3.5 billion in operational costs. Our stock went up a little bit when we did that announcement. So this may be science fiction for some companies and organizations. And of course, you cannot start with 10 different agents and automating everything day one. You have to take it step by step. So start with an assistant and then start building out your agentic AI capabilities. Okay, what about models? IBM has a strategy. We have a model strategy. We know that one model will not rule them all. We have a multi-model strategy. We also know, so one model will not rule them all. We develop our own models. We call them the Granite. We use open source models. We have third-party models. We have collaboration with Meta, for example, with the Llama models and Mistral. And we can use them on our platform. We also know that bigger is not always better. But bigger most likely means more power consumption. They're more expensive to run. The bigger they are, the more expensive they are. So try to find a model which is as small as possible, but still provides good answers or good performance. So we have a model family, or we provide different models, both from our own and from, this is Google model, this is Meta models, etc. And of course, we want to run this both on the cloud, both IBM Cloud and other clouds, and on-prem. And if you actually need to call out to, for example, OpenAI or Anthropic Claude, which are closed ecosystems, we actually have something we call the model gateway. So using the model gateway, you can route your requests either to one of the models that we provide on our platform that you can run on-prem, or it can route it to one of the third-party models hosted somewhere else, more like a black box. So we provide lots of flexibility in invoking models. Another thing is retrieval augmented generation. So when you want to feed your own data into a system that uses RAG or LLMs, you want to use retrieval augmented generation. And of course, we've been doing this for quite some time using programming Python and using libraries such as docling. So you have your document systems, you have your unstructured data, you write your Python code, you read this and you chunk it and you put it into a vector store, etc. It requires a lot of tweaking to get it right. So what we have in our platform is also more out-of-the-box solutions. So we have something called the Watsonx data integration. We can take documents, feed it into this, and where it is structured data, we can extract the structured data, and we put this into an open lakehouse using Iceberg format, which is an open table format. And when it's text, we take it and we put it into vector embeddings using one of the vector databases that we provide. We have out-of-the-box solutions for basically doing this piece of RAG. And when you have this structured data and unstructured data, you can start putting AI governance on top of it. And then you can consume it based on what your needs are. If you're doing Gen AI, you use vector databases. If you want to do machine learning, you can use Spark. If you want to provide data to BI or Power BI, for example, you may want to use a Presto SQL engine. So there are out-of-the-box solutions. And if you use the Fusion machine, then we actually also have another technology called CAS, Content-Aware Storage, which you can actually point your Fusion machine to your document libraries. And we scan that and we vectorize the data and we keep it updated when you remove and add documents, etc. into some kind of a puzzle, we have a reference architecture. If we start from the bottom, of course, hybrid cloud, that means, for example, Skatteverket, I know you want to run everything on-prem, fine. We can do that. We also work a lot with the Swedish regions because they also want to run everything on-prem. And I know that last week we had someone here who had been in a meeting with Region Halland, and they said everything has to be on-prem. We can do that. So we have 3 different pillars: foundation of AI, building AI, and using AI. So if you start on the left, you have data sources. We know there are on-premise and cloud data sources, different types, structured and unstructured, streaming data and at rest. So there's all different kinds of data and velocity of data. So we need to integrate data. Sometimes you want to run batch jobs, ETL jobs. Sometimes you need to do streaming. Sometimes you want to do data replication between databases. Sometimes you want to design a data flow and you want to run it on the cloud and on-prem. We have technologies for data virtualization. So what's data virtualization? Basically, that means if you have multiple databases, we can put a virtualization layer on top of that. So it looks like we create a virtual view on the fly. So it looks like, for an application, it looks like those databases is one database. It makes it easier to kind of like combine different data sources. And then if you want to store data, we have traditional data warehouses. We have lakehouse for both structured and unstructured data, using open data formats like Iceberg and Parquet, etc. Vector databases and NoSQL. Yeah. Then when you have data, you want to share data. You want to make data available for your teams. So a new trend or an interest on the market is actually to create data products. So you have a data owner and he owns that data within an application, for example, and he wants to make that available to his peers. So you can publish your data sets in a marketplace internally. And then you can kind of like go shop for data internally within your organization. So we have lots of solutions for managing data and sharing data. Then we want to build. Of course, we have tools for building machine learning using Python, R, etc. Generative AI, writing the prompts, building agents, the new type of agents, and doing data prep, etc. And then, of course, you want to consume this. We have the Watsonx Orchestrate for orchestrating agents and infusing data into applications and BI and AI, BI, etc. Yeah. Then, of course, we want to have governance of the data. We have a data catalog. I will show it briefly in a few minutes, where you can register your databases and you can start searching for data. When you look in the catalog, you can also see the data quality and see if it's sufficient enough to use for a project. We have data lineage components, so you can track the life cycle of data. If you run ETL jobs, you can make sure that data has been transferred correctly, etc. And of course, when you start working with AI, we have AI governance, so you can be compliant with European Union AI Act, and you can track your AI usage. And of course, MLOps, which is one of the white papers in this project, how to deploy models and how to keep life cycle of models. Then we have the next part, security and data protection. Maybe that was what you were talking about a little bit, Robin. We have solutions for, of course, tracking the data, making sure that we comply with rules and regulations. Maybe if you are a data scientist and you go and search for data, maybe you should not be able to see the sensitive data. You want to mask first name, last name, address, credit card numbers, social security numbers, etc. We can do that kind of data protection. One thing I would like to point out, how many people here knows about quantum computers and the new risk that quantum computers are putting up? I cannot see anyone raising their hands, or how many have raised hands. This is something that we're also working with. Very shortly, quantum computers are being developed. IBM is one of the leaders. In the future, we don't know exactly which day, quantum computers will be able to break public key encryption. That means that the TLS protocol is going to be unsafe. That means that RSA 2048 is going to be unsafe. So a lot of people don't understand this yet, but we have a new year 2000 problem coming up. The work to secure data in the future for quantum threats is a bigger problem than the year 2000 problem. So I'm not going to go into this, but we also have solutions for keeping data quantum safe. So this is a totally different topic, but it's a big topic. So this is kind of like IBM's reference architecture. I have not put product names into this, but we have products kind of like to cover all of these pieces. The last week, the 2 weeks before, Jens from SEB did a presentation on how they are working with machine learning. I thought this picture was really good. They had kind of like thought out what should their machine learning process look like. So I asked him if I could use this and kind of like map our capabilities into his scheme. So if we start here, they want to identify some need. Yeah, we do that using or we document that using our AI governance tool. I will show you that in the demo. So here you can register an AI use case. You can use data catalog and look at data quality and look at the data product hub to see what kind of data you have. You can use AI governance, kind of like document it. You can use a feature store to see what kind of machine learning features you already have. And you can create jobs. You can use AI governance to create your production flow. MLOps, you want to start working with data governance. You may want to do integration, data virtualization, data replication. You want to do data preparation. Maybe when you have kind of like created your final data set, you want to protect certain parts of it, certain columns. It may contain credit card numbers or social security numbers. You want to protect pieces of it. And then you want to use machine learning or maybe Gen AI and kind of like start working here. And at the end, when you have done your project, you want to save what is important. So you take your machine learning models and your data sets and you register them in the catalog. Maybe you register your data sets in the marketplace. You build up your feature store, etc. So we have kind of like capabilities to support a process like this. So this was all I had to say. Quick overview of our capabilities and a quick demo. So I hope this kind of like gives a really high level overview and inspires further conversations.
I must say that the width of what you seem to be managing at IBM is really impressive.